that's the strain transformation equation presented earlier. Now also strain transformation that apply with the Mohr circle also have analogous to stress. So let's talk about that here. Mohr circle for strains. So it analogous to stress that we learned in the previous class, and it allow determination of shear and normal strains on any plane. Allow determination of shear and normal strain at any plane. Any plane. So give you an example here. If we have a strain block, so we have instead of sigma we have epsilon. Let's assume epsilon x 50 micro inch over inch for example, and epsilon y in this case in the body in compression going down into the block, so 100 micro inch over inch or millimeter over millimeter, so that the other way, and then go down here. So the that is the normal strain, and now the shear strains. Let's assume that gamma xy, and we have that is gamma yx, so that gamma equal to 150 micro inch over inch. And the question is how we can draw the Mohr circles. To determine the Mohr circle, we need to find out the center, location of the center, and then the radius. So if you apply and recall what is the here we have in this case epsilon x equal to 50 micro and inch over inch. So and then we had epsilon y negative 100 micro and gamma over 2 gamma xy equal to, by the sign convention for Mohr circle, if you recall. So in this case the gamma, if you apply equation, then it for the positive y x plane, the vertical plane on the right, it going down, so it negative if we use the equation to that way. As you can see, never 150 micro inch over inch. Okay, and then we have gamma over 2, because that's the analogy we do later on. So you have gamma xy over 2 equal to divide by 2, so negative 75 micro. If we use the Mohr circle, we have a note here, it equal to 75 micro in Mohr circle. Why is that? The sign convention for the shear stress and shear strain for Mohr circle is defined by the clockwise rotation. It will, if that stress or strain tend to rotate the block, the blue block here, clockwise, then it's positive. Counterclockwise, negative. And you can see for the shear strains on the vertical plane on the right, it tends to rotate clockwise. So that's why positive in the Mohr circle and negative in the analytical method when you do the calculation. So from that we can go ahead to find out the sigma average and sigma and the gamma max over 2. Sigma average equal to epsilon x plus epsilon y over 2, 50 plus negative 100. We will get that one is negative 25 micro, and we have gamma max over 2. That is actually the radius of the Mohr circle. And if you recall that gamma max over 2 equal to that equation here, so we just apply that in here. It will be square root of epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. So from that we can have here 50 minus of minus 100 divided by 2 square plus 150 over 2 square, and that equal to about 106 micro, and that actually the radius. So as you can see the radius now. So from that, what do we have? The center and the radius, right? So AB for the Mohr circle. We have AB, the center, equal to epsilon average 0. In this case, we have negative 25 micros 0. And then we have the radius equal to everything tau max. Now tau become gamma over 2. So gamma max over 2. And from that equation we have 106 micro. And from that we can go ahead to draw the Mohr circle for this equation. So we have the horizontal, it sigma, now it's epsilon. Vertical, and it will be micro, inch over inch. And the vertical, it used to be tau, now it's gamma over 2, not gamma. Something, normally we make a mistake, gamma over 2. And the center is negative 25, 0. So let's put that here. Every point is 25, so we have that is 25 here. So you have that is the epsilon average 0, that is the center, and the radius is 106. So we have about, so that is 25, 25, 25, 25. So that is about 100. So it's 100 April here. So one. So we have Similarly, we have here. So we can draw the circle for more circle. Okay, so that is not very representative the circle correctly, but that try my best to do. And unless you want me to redraw it, let's redraw it here. Make a good scale. If it is scale here, then you go up nicer with the scale. So it should be start from here. Just square 106 here. It's not better, but let's see that a circle. So we can have this the normal strains, principal strain. You see epsilon 1, as you can see, and this will be epsilon 2 if you do it correctly with your compass. I don't have compass in here, unfortunately, but that's not a good skills, right, everyone? And where is the positive x-plane? Positive x-plane is, as you can see, 50 and gamma over 2 75, as you can see there for the Mohr circle. So put it somewhere 50, so around here, that one for positive x-plane. So that width is the positive x-plane, and that is epsilon 50 and 75 micro. Gamma over 2, not gamma. And then if you go to the other side, that it will be the y-plane, which is the horizontal plane on top. Horizontal plane on top, that is y. How to define that, we already talked about. And that y-plane is negative 100, negative 75 micro. So as you can see, and then gamma max. In this case, gamma max over 2 divided by the line from here, go up, not there, and that gamma max. And that gamma max, you see, gamma max over 2. Everyone see that, because the axis that we have it gamma over 2 for the analogies we have. And the angle to measure the principal shear strains, so you can have that from positive x-axis. We define it from that angle to here, so we have that 2 theta s. Everyone okay? And then we also have that is the angle from here to there is 2 theta p1, and we already know. So all the way from the positive x-plane, and then from there to here, so we have 2 theta p2. So that's what we have for the Mohr circle. I apologize for my circle. It's not really a circle. It looks like an egg, but very abnormal. But with that, you have an idea of how to develop the Mohr circle for strain, which exactly similar to the for stress, but whatever tau we have to replace with gamma over 2. That the common mistake we have.